All right, good morning. We are starting our new chapters, chapter 4, starting with section 4.1, solving the systems of linear equations. And in section 1, we do it by graphing. So here we are with graphing again. Last section of graphing. So first of all, we want to determine whether 3, 9 is a solution of this system here. I went and explained all that to us, but here we've got this 3, 9. 3 is x and 9 is y. We already know that, so I'm just going to plug it into these equations here. And 3, 9 has to satisfy both equations, not just one of them. Alright, so this would be what? 5 times 3, 3 for the x, and then this is going to be minus 2 times y. Y is 9. Does that equal negative 3? Okay, so we got 5 times 3 is 15, minus 2 times 9 is 18, equals negative 3. 15 minus 18 is negative 3, equals negative 3, which is a true statement, so that is satisfied for the top equation. All right, does 3, 9 satisfy the bottom equation here? So that would mean 9 for the y equals 3 times 3 for the x, and it's quite obvious that 9 equals 9. So therefore, 3, 9 is a solution. Remember, determine, that tells us our answer is going to be yes or no. So I could say yes, or anything that indicates a positive yes. Okay, so that was our practice problem 1. Note, practice 1 is on the left side of the page in your textbook, page 284, left side. These are practice problems that I'm going to be doing this time. All right, I'd like to change it up, do examples, practice problems this time, problems from your homework. But I'll go this way and it'll cover all the different types of problems you're going to have in your homework. All right, next problem. Okay, here's our next problem, practice problem 2, aka P2 will be the notation for practice 2. Not page 2, practice problem 2. All right, so let's go over here, and same game. I'm going to convert this to be 2 times 3 minus y, which is negative 2. Does that equal 8? I've got 6 plus 2 equals 8. 8 equals 8. All right, got that? And tried for the second equation, the bottom equation here. So I'll do that underneath it here, and that's going to be what? 3 plus 3 times negative 2. Does that equal 4? 3, bring down the 3. 3 times negative 2 is negative 6, equals 4. 3 minus 6 is negative 3. And negative 3 does not equal 4. It's not a solution. No. Okay, it's got to satisfy, 3, 2 has to satisfy both equations, and it's not. It's doing one, not the other. Okay, here's our system for practice problem 3 here. Again, this is on page 285 on the right side of your page, and they're giving us what we have to do here is we have to graph these lines, 2 lines on the same grid, and we will watch for they are either going to they're going to cross somewhere to give us a solution, they're going to be parallel, or they're never cross, which indicates no solution, or they're going to be the same, or it's going to be the same line. They'll be the same line, like a line on top of each other. Okay, which indicates infinitely many solutions. All right, so we've got to graph this line here. Let's graph this top one first, and I'm going to say I'm going to change this to slope-intercept form. So this would be y equals, and think about this, we're going to add 3x to both sides, so that would make it positive 3x, and then the minus 10 stays. So here's our first equation. We can graph that, and well, let's graph it now. My y-intercept is negative 10, so let me scroll down here a little bit and go, well, this is going to be a little bit of a problem. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, and I've got to guesstimate 10. 9, 10. I'll just say it's here. See if I can get my, I don't know, just estimating that to be. Okay, so that means that's indicating 2, maybe a little bit lower. Maybe just a smidgen lower. Because I got to be accurate now with this one, as accurate as I can. So let's see, if I go 1, 2, I'll go here. I'll see that's about 2. So that gives me, I'm at negative 10 here. Let me indicate that. Negative 10. That's this line extended out. And I've got a marker here. Okay, let's see what else we got. Then our slope is 3. Go back up here. This is our slope. It's 3 over 1 now, right? So that means I'm going to rise 3 and run 1. That's to the positive. So here's my point here. I'm going to go up 1, 2, 3, and run 1. So here are my 2 points. Okay, I'm going to get a straight line and connect the 2. And again, I'm just doing the best that I can with that. And okay, going through the points exactly. Let's see how we do with that one. All right, next I'll graph the second line. If I have to extend that up, I will. Okay, and I'm going to get my pencil back. So now I've got to graph this guy here. This time I'll use the t-chart, x and y. The x and y are on the same side, so that means when x is 0, y is going to be, let's see, negative y divided by negative 1. Y is going to be negative 6. When y is 0, x is going to be 6. So there's my 2 points of my second equation. 0, negative 6, 1, 2, 3, 4, 5, 6, and 6, 0. Well, you like that black line. 1, 2, 3, 4, 5, 6. This is 6, 0. And I'm going to connect these 2 dots here. Connecting these 2 dots with a straight line, like so. Okay. So it looks like the point of intersection is here. And I'm not sure. I'm going to take those whole numbers and see if this will work. This point here, meaning I could be slightly off. So what is the name of this? This is 1, 2, and down 1, 2, 3, 4. So this point here is 2 comma negative 4. 2 comma negative 4. I'm going to plug this into these equations here and see if they're solutions. Let's try. I'm going to try this top one here. This would be negative 3 times 2, 2 for the x, plus y, but y is negative 4, plus negative 4. I'll do it this way. Does that equal negative 10? Negative 10. All right, negative 3 times 2 is negative 6, plus negative 4 indeed does equal negative 10. All right, so negative 10, of course, equals negative 10. I don't have to do that, but all right. And just for the heck of it, I'll check out the second equation here, meaning 2 minus negative 4. Does that equal 6? 2 plus 4 equals 6. So it checks. That was our solution. Remember, our lines were slightly off, but, because we can't get these perfectly straight and accurate when we go off the chart especially, then I can adjust and make an educated guess to say that the point of intersection here was our solution. We don't want to get into fractional amounts with two lines going in between. That's ridiculous. Okay, that's it, our first one. That's the game. That's what we're doing here. Graphing two lines on the same grid. Next problem. Okay, next, practice problem 4. Again, graph. That's all I'm doing is graphing these two lines. How about this guy here? I can rearrange it to be in slope-intercept form. And remember, you could always write these separately too, by the way. Like you could scratch this out. Let's see if I can do that here. I could write it up over here, y equals 1, and work underneath it if you want. Sometimes I do that kind of a thing. Whoop. Let's see. Hold on. Okay, that's better. And now, as I was saying, you can graph these separately, do a little work here if you want. Put your t-chart underneath it, or rearrange this to be in slope-intercept form. So if I put this in slope-intercept form, I'm subtracting x from both sides. How'd that get so thick? And I'm going to have 3y equals negative x minus 1. And then divide everything by 3. And what have I got? Y equals, I want to make this negative 1 over 3 x minus 1 over 3. Ugh. So you can see what I'm on about. My y-intercept is negative 1/3. So it may be about here. Make it nice and thick. My slope is negative 1/3. So I'm going to go down 1 and over 3. Connect. Connect my line here. Okay, we'll go along with that. And then this other point is just simply, this point here is this graph here is y equals 1. Y equals 1 is a horizontal line at 1 on the y-axis, so that is here. And my line's going to go across this at 1. I want to make sure it's perfect. Perfect as can be anyway. And then I see the point of intersection is here. However, wow, could I say it's here? I don't know if we could say that's what this point is here. That's the problem with this. So if I guessed it to be this intersection here, where I've got whole numbers, then that would give me what? 1, 2, 3, 4. That's negative 4, comma 1. Negative 4, comma 1. Would that satisfy these equations? Well, this one's easy. Negative 4, comma 1. There is no x, so that means y is 1. So 1, 1, 1. What the heck? 1 equals 1. There we go. 1 equals 1 for that 1 here for the y. Okay, let's go over here and let's substitute. So if x is negative 4 plus 3 times y is 1, does that equal negative 1? Negative 4 plus 3 equals negative 1. Negative 1. So yes. It does. So this point, I had to do a little rounding there to whole numbers. Okay, and it worked. All right. Next problem. Okay, here's another system. This is practice problem 5, page 286. And notice I split them up this time. Give me a little workspace underneath. So on this left one here, I can make my t-chart this way. And I can do the xy intercept method. When x is 0, y is going to be negative 6. And when y is 0, put it here, when y is 0, x is going to be 2. Okay, hope you're okay with that. I'll graph this line. 0, negative 6 is going to be, 0, negative 6 is down here. 1, 2, 3, 5, 6. And 2, 0. 1, 2 zeros here. Draw my line for it right away. Okay. And let's graph the next line. That would be this here. So this is done. So now I got 6x equals 2y. Section that off. So let's see what I can do here. How I could rearrange this to be in slope-intercept form by dividing by 2. A little backwards, but we'll straighten it out. So I end up with what? Y equals 3x. If you don't like it this way, I can just flip it around to be y equals 3x. Then the question becomes, what is the y-intercept? This is in slope-intercept form, so indeed I could make this be plus 0. If I need that there, or want it there. Just to know it is kind of good too. Alright, so y equals 3x plus 0. So I'm starting with 0 is my y-intercept. My slope is 3. I'm going to go up 3 and over 1. Because this is really 3 over 1. Okay, scroll up a little bit. Now, as you can see, when I connect my dots here, I potentially have what kind of lines? I have parallel lines. Okay, I can confirm this here. My slope here was 3. Here my slope is 3. I did the slope-intercept form here, and what do we notice? If I bring the 3 over here, it becomes negative y equals negative 3x. And let's just concern ourselves with the slope. I don't have to worry about the 6 now. Dividing by negative 1, I get positive y equals 3x. So my slope is 3 here as well as 3 here. So the slopes are the same, so therefore I get parallel lines, which means there is no solution. No solution, because those lines will never cross. And if they were to cross, then I'd have one solution. Okay, doke. All right, next, practice problem 6. Same way. I put these horizontal to each other or across from each other instead of stacking them. My method here is to use the t-chart. When x is 0, what's y? -4. When y is 0, x is -4. Plot and draw the lines. So I got 0, -4 here. And -4, 0. Left, 1, 2, 3, 4. Okay. There's that line. And how about we graph the second line? Okay, same way. These look like multiples of each other, so I'm gonna, x and y are on the same side. So that means when x is 0, y is gonna be -4. And how about when y is 0, x is -4. Same numbers. Uh-oh. We got something going here. What is it? 0, -4 is here. I'll switch colors. 0, -4 is here. And -4, 0 is here. And when we draw this line, it is what? I'll go off center just a little bit. No, I won't. There's the line. So that's telling us it's the same line and that there are infinitely many solutions, or the all real numbers we can use for that. All real numbers is our solution for practice problem 6, or infinitely many solutions, however you want to say that, determine that. All right, so there's an example of that all real number problem. Okay, in practice problem 7, they want us to change gears up a little bit and say without graphing, determine the number of solutions of the system. Okay, so when you think about these graphs, let me see, let me go off screen here a little bit. When you think about these graphs here, if I have, here's a graph, so what are the possibilities? Here I got 1, 2, 3 possibilities for graphs. Okay, the first one is let's see, the first one here is going to be 2 lines can be graphed on a grid, and the 2 lines will cross and they will form a intersection here, which results in one solution. Okay, the other possibility is the 2 lines may form 2 lines that are parallel. Well, they'll never cross each other, which means there is no solution. And then the third possibility is, like we experienced in the previous problem, that the 2 lines are the same. They are on top of each other. And that indicates infinitely many solutions. All real numbers are the answer. So that's what we're looking for here when we're putting these equations in slope-intercept form. Now I definitely want to do that. Okay, so let's go back here and let's do that with these equations. All right, so now I need some room to work possibly, so I'm going to get rid of this and bring it over to set it up side by side. No, what am I doing here? All right, so let's try that. This is going to be going crazy here. Going a little crazy. There. Do that. Get my pencil back. Have a white pencil. There we go. Okay. So what I want to do again is I want to arrange this to be in slope-intercept form. So let's subtract 5x from both sides. And I'm going to compare the slopes. So I've got 4y equals negative 5x plus 6. And then to get y by itself, I'm going to divide everything by 4. And how about this? Y equals negative 5 over 4x plus 3 over 2. Alright, so this side is done. Here's my equation here. Here I'm going to do the same thing. How about it? Can I subtract x from both sides? Negative y equals negative x plus 3. Get the y by itself by dividing everything by negative 1. And y equals x minus 3. Okay, and now we compare our slopes. Well, this slope is negative 5 over 4, and this slope is 1. They're not the same, so they're not parallel. They're not reciprocals of each other, so therefore they are neither. So they're just two lines that cross somewhere. You know, they just cross somehow and somewhere, not forming that 90-degree angle, but they still cross somewhere. Okay, so this has one solution. One solution for this problem here. Okay, let's do one more. Hopefully there's one more here we can do. All right, be right back. Okay, here is practice 8. This is practice 8. Okay, I can just say practice 8. I split them up already, so I can go ahead and rearrange this in slope-intercept form. So this one on the left here, do it separately. I'm going to add 2/3 x to both sides, 2 over 3x, and plus 2 over 3x. And I end up with y equals 2 over 3x plus 6. Okay, so my slope here is 2/3. That's really what I'm concentrating on. The one on the right here, I'm going to divide everything by 3 to get the y by itself. And y equals 2 over 3x plus 5 over 3. And there we have it. I got a 2/3 here for the slope and a 2/3 here. So that tells us that there are, without graphing, determine the number of solutions. We have, what do we have? The lines are parallel, so we have no solutions. We got to think about that at the end. You know, what, depending on what our lines are. If they cross, remember, we're going to have one solution. I'll abbreviate. If the lines are parallel, that equals no solution. And if they're the same line on top of each other, then that indicates many solutions. All numbers are solutions. All real numbers. Okay, and I think that's it for 4.1.